So this is lesson 1 of Algebra 2, polygons, triangles, transversals, proportional segments on page 19 of your book. And just some real quick definitions here as far as polygons are concerned. Polygons are just many angled objects, and the proper definition of a polygon means that we have a group of line segments that are attached at their ends, and it doesn't really matter what shape they're in, but a couple things that are necessary. They have to be simple, which means the one I have there is simple. This is not simple because the lines cross, so that cannot happen. They also have to be closed. You cannot have a polygon that looks like that because there's an opening right there. So they have to be closed, and that's pretty much it. If we have a polygon, or we have an object that does not have a line segment, it has, say, a curve like that, then that also is not a polygon. Another part of the definition, or part of the terms here on polygons, is we have what are called convex polygons and concave polygons. Okay, concave, or a polygon, in order for it to be concave, means that we can put, or convex means we can put two points on the figure and draw a line, and it will not go outside of the polygon. Concave means we could put 2 points on the polygon and draw a line, and it goes outside the polygon right there. It also looks like a cave right here. You can go right inside there, and so that would be a definition of a concave polygon. A regular polygon is different than your run-of-the-mill polygon, because a regular polygon has equal length of sides, and it also has equal measure of the vertices. So a regular pentagon would, well, kind of look like that if these were all the same measure, and we'll put a little tick mark there to show that everything with one tick mark means that they're all the same angle. And if I put a tick mark here, 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 and here, it tells me that all the lengths of the sides are the same. So that's what makes it a regular pentagon. Now if I had a pentagon that looked like this, that would be just a pentagon. It would not be regular because the sides are not all the same length and my angles are not all the same degree. So difference between a regular and a not irregular, I guess is what they're called, polygon. Okay, so a couple more definitions here. One is consecutive. When you have a consecutive side, that means that you have sides that are right next to each other. That and that are consecutive. This and this are consecutive. But we'll do this in blue. This line right here and this line right here are not consecutive because they're not touching each other. It's the same way with vertices. This is consecutive with this, but this is not consecutive with this because there's one right here in between the two. So that's good to know, especially in story problems when they're asking you about consecutive sides. Alright, another thing we're going to look at here, and I'll draw that in pink so you can see what we've got, and those are called these are called diagonals. Diagonals mean they skip. They go from one vertex to another vertex, but they skip a vertex. So these are all diagonals because they skipped this one and they skipped that one. Also, when you're looking at a rectangle and you're interested in diagonals, it would be this one here and this one here, because notice we skipped this one. If we're looking at triangles and we're interested in a right triangle is a triangle that has one of the vertices a 90-degree angle. And this is shown by putting a little box there showing that that's a 90-degree angle. If there's not a box there, you cannot assume it's a 90-degree angle. We have also what are called obtuse triangles. An obtuse triangle is an angle that is greater than 90. So as long as one of the angles is greater than 90, in fact in a triangle only one angle can be greater than 90. And the other type of triangle is called an acute triangle, where none of the angles are greater than 90. So a right triangle where one of the angles is 90, an obtuse where one of the angles is greater than 90, and acute where none of the angles are 90 or greater. Remember, when you add up all the angles to a triangle, you get 180 degrees. And sometimes you get a triangle where none of the sides and none of the angles are equal to each other. If that's the case, if this was 6, this was 7, and this is 4, that would be what is called a scalene triangle, top of page 21. And if we have a triangle where 2 of the sides are the same, which means that 2 of the angles must also be the same, we have what is called an isosceles triangle. If we have a triangle where all of the sides are the same, we have what is called an equilateral. And if we were also to make a triangle where the angles were the same, we have an equal angular triangle. So when we have an equal angular and an equilateral, if we have one that's an equilateral, it's also going to be equal angular, and vice versa. So if I have a triangle like this, and this right here tells me it's isosceles, and like I'd said before, if these two lengths are the same, then the angles here and here also must be the same. So it's the angle opposite and the angle opposite. So it'd be easy for me then to find y, because I said that all triangle angles, all three angles added up, equal 180 degrees. So that means if we took the degree of angle y plus 50, and if this is 50, this has to be 50, then I can real easily find out what y is, because 50 plus 50 is 100. So y has to be equal to 80. And x then, if we called this x, that would have to be equal to 50.